In this part, we want to work on background idea is remainders of consecutive numbers. Sometimes we have some numbers, for example, like here 2 to 10, and we want to find remainder of n when divided by this. We have this problem in AMC 12B 2021. Also, we have similar idea in BMO British Mathematical Olympiad, next prestigious national Olympiad exam after USA, after AMC, and it is BMO round 1. So I will tell you, I will explain for you this idea in this AMC 12B problem, and then you can work on this idea as you can work on this problem as homework to get good at this idea. It is not hard idea. So let's see it is what, and if you wanted more homeworks or wanted to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, it says for n last problem 25, for n a positive integer, let Rn be the sum of the remainders when n is divided by 2, 3, 4, 5, 6, 7, 8, 9, and 10. For example, R of 15. So R of 15 is what we consider the remainder. It says 2, 3, 4, 5, 6, 7, 8, 9, 10. 15 when divided by 2 is 1, when divided by 3 is 0, when divided by 4 is 3, when divided by 5 is 0, when divided by 6 is 3, when divided by 7 is 1, when divided by 8 is 7, when divided by 9 is 6, when divided by 10 is 5. So if we add 1 plus 3, 4, 4 plus 3, 7, plus 1, 8, 15, and 21, 26, okay? The problem says how many two-digit positive integers n satisfy Rn equal to Rn plus 1. Let's check. For example, let's check R16. See, is R16 equal to R15? 16 divided by 2 is 0. Divided by 3 is 1. Divided by 4 is 0. Divided by 5 is 1. Divided by 6 is 4. Divided by 7 is 2. Divided by 8 is 0. Divided by 9 is 7, divided by 26. Now, we have two types of remainders. The first remainders are remainders when divided by 1. For example, look, it is divided by 1. It will be add by 1. 0 plus 1, 3 plus 1, 1 plus 1 here, 6 plus 1, 7, 5 plus 1. And we have some other remainders that it will be 0. Okay? Why it happens like this? Because 16 is multiple of those numbers, okay? So, we understand that n plus 1 will be multiple of that, 16 will be multiple of that. And here what happens, it will be minus 1, because it is 2, the remainder is 1 here, the next part will be 0, it will be minus 1. Here it will be minus 3, because it is 4, the greatest remainder is 3. After that it will be 0, so it will be minus the greatest remainder. 7, it will be negative 7. So let's see what happens. Some remainders, for example, if we check all 2 to 10, let's see what happens for Rn and Rn plus 1. Again, look, also in this problem, we can say a small example useful. So let's check Rn plus 1. For some numbers, we have plus 1. For example, suppose we have some plus 1 here, plus 1 here, plus 1 here. We have some plus 1s. Suppose number of them is 1, 2 to k. And we want to see what happens for Rn plus 1 minus Rn. So we have k plus 1. And let's see get the green parts have what effect. So suppose, for example, for remainder a1, it is a1 minus 1. Then next part it will be 0. So it will be minus a1 minus 1. And for a2, we have same thing. It is the remainder is a2 minus 1, so it will be negative a2 minus 1 will be 0. To am, it will be am minus 1 minus am minus 1. It will be 0. So it will be what? It will be minus a1 minus 1 minus a2 minus 1 minus am minus 1. So let's calculate this addition and subtraction. It will be k minus a1 plus 1 minus a2 plus 1 to minus am plus 1. So how many plus 1 are there? M. So it will be k plus m minus a1. We can factor plus a2, factor from negative to am. Now k plus m is what? K is number of red parts, m is number of green parts, so it will be number of all parts. So how many numbers are there here? 2 to 10. So we understand this part, 2 to 10 is 9, minus a1 to am. So a1 to am, you should select some numbers that their sum is 9. So we want that this part be 0. The problem, because the problem says find Rn equal to Rn plus 1. So Rn plus 1 minus Rn is 0, and two of them, it says n is two-digit number, right? How many two-digit number? N. So n can be 0 to, two-digit number 10 to 99. Now we conclude that a1 plus a2 to am equal to 9 because it is 0. And ai's are what number? They are numbers that the remainder when divided by n plus 1 is 0. So ai divides n plus 1. Okay, because n plus 1 when divided by ai is 0. And other numbers are not, n plus 1 are not is not multiple of them. Okay, so let's check this part. Sum of them equal to 9. And you know ai can be from 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the only numbers that ai divides n plus 1. So let's check. Sum of some numbers equal to 9. So one example is that we have only one number, 9. But if you have only 9, let's check. If you have only 9, that n plus 1 is multiple of that. So n plus 1 is multiple of these 9, but is not multiple of these numbers. But we have a contradiction. Why? Because we know if n plus 1 is multiple of 9, then it should be also multiple of 3. So that's a contradiction. We can't have one number. Now let's consider sum of two numbers equal to 9. So the smallest one is 2, 7. The next one is 3, 6. And 4, 5. Okay, we have three cases. So if it is multiple of 2, not 3, not 4, not 5, not 6, 7, 8, 9, 10, we will see it's okay. So what are the numbers that are in these from 2 to 10 are only multiple of 2 and 7? The first number is what? Pause the video and try to find it on your own. Is 14. And we have one more number that satisfies this sequence. Maybe you say 28, but it's not. Because 28 is multiple of 4. It should be only multiple of 2 in these numbers 2 to 10 and 7. So pause the video and try to find next. We have one more number that satisfies this. Why? Because it's multiple of 2 and 7 only. So 2 times 7 or 2 times 7 squared. It's 98. So we found these two numbers so far. Now let's check 3 and 6. Suppose the number is multiple of 3 and 6. So we know that when it is multiple of, let me write, when it is multiple of only 3 and 6. Because it is multiple of 6, it is multiple of 2 also. So again, that's a contradiction. 4 and 5. Again, we know when it is multiple of 4, it should be multiple of 2 also. So that's a contradiction. So we've considered for three cases. Now for two numbers. Now suppose sum of three numbers equal to 9. Okay? So if one of them equal to 2, then then sum of other two should be 7 to equal to 9. So it will be what? It will be 3, 4. So we understand that if you have three numbers, if you select the three smallest one, it will be 9. So it is the last case we should check, because for three numbers, if we substitute one of them with a greater number, some won't be 9. And if you have, for example, four numbers, if you select only 2, 3, 4, 5, it will be greater than 9. So the last case we should check is this. So 2 multiplied 2, 3, 4, not 5, not 6, not 7, not 8, not 9, not 10. So here again we have a contradiction. Try to find it on your own. Pause the video again. It is multiple of 2 and 3, so it is also multiple of 6. So again we've reached another contradiction. So we found 14 and 98 for this problem. The problem says what? How many two-digit positive integers n satisfy this? So, but let me tell you something. Here, the n's that we found, they are n plus 1 because we are considering n plus 1 is multiple of what? N plus 1 is 14 and 98. So n is 13 and 97. Okay? And the problem says it's not important for the problem, only it wants how many. So the answer is C, 2. And as homework, try to solve this BMO problem, BMO Round 1 British Mathematical Olympiad. And as I said, if you want to learn other ideas, 40, 50 important ideas in geometry, number theory, algebra, and combinatorics that are useful in AMC, AIME, IMO, USAMO, USAJMO, and BMO, and all other exams, feel free to send message my WhatsApp number in the description and comments. Okay, so we finished this idea, remainders of consecutive numbers.